Hello everyone and welcome back to the Silent Defender. This is Python series and the topic we are covering today is errors and exception handling. So before we start, let's create a separate branch and a directory for this. Okay, so we have created a new branch by the name of error and let's create a directory. And inside this, let's create a file by the name of tutorial. Okay, so we are good to go. So currently, if there is any type of error in the code, the entire script will stop. Let's try to demonstrate this with an example. Let's say you have x is equal to 5 and y is equal to 0. And you do a mathematical operation which is x divided by y, which in this case will be 5 divided by 0. And then you print the value of x by y is, and then you put z here and we can use f strings. And after this, let's just end this with execution complete. Now let's try to run this code. If you run this, you will see that we are getting an error. The error there is that zero division error, which means division by 0 is being performed. Now one more thing to notice here is that the error occurred at line 4 here. As you can see in this case also, that in line 4 we have an error. So anything beyond that or anything below that, we can't see the output of that on our screen. So whenever an error is detected, the script stops the execution there and the rest of code is skipped. Now we can use error handling to let the script continue with other code even if there is an error. And for that we have three keywords: try, except, and finally. Let's look at them. So the try block contains the code which needs to be attempted or which could generate any error, which in this case is this line, z is equal to x divided by y. The except block contains the code which will be executed in case we see an error. And the finally is the block which contains the code which will be executed irrespective of whether an error was generated in the try or not. Let's try to replicate this exact example using these three blocks. So let's say we put x is equal to 5 and y is equal to 0. Now the operation of z can be performed inside the try block. Now let's imagine if there was an error in this. So what we can do is we can print something here. The division by 0 generated an error. Okay. And afterwards we have a finally block which will execute irrespective whether there was an error or not. So we will write here that print irrespective of what happened in try block, this code will execute. Now let's try. As you can see, this time we did not get any error, but we got the output that the division by 0 generated an error, which was the except statement since we attempted a division by 0. And after that, in the finally block, we can see the output irrespective of what happened in try block, this code will execute. So if we had something like 1, which will not generate an error in this case, and let's run it again. So as you can see, the except block did not execute. Why? Because there was no error in the try block, but the finally block executed this time also. So you can see irrespective of what happened in try block, this code will execute. So those are the try, except, and finally block for you. Now along with these three, we also have the else block. So what we can do is that after the except block, you can add one else block. So if you have an exception in the try block, the code in the except block will execute. But if you don't have an exception in the try block, the code in the else block can be executed. And finally, as it was previously, irrespective of what is happening on the top of it, this will be executed. So let's put a print statement here. There was no error and the execution was successful. And let's run it. So now you can see there was no error and the execution was successful. Why? Because there was no error in the try block. But if we put 0, you can see the else block does not execute. Instead, the block of except and the block of finally provides their output. Now let's try to look at that with a real world example. Let's try to take an input from the user. If we have not discussed it before, we can take input using the input function. So let's store the input inside a result variable and use input, and let's ask the user for enter an integer, and then let's print it out. The integer is result. Also, I will also print out the type of result, and then let's see what's the output. Okay, so it's asking for an integer. Let's enter number 7. Here you can see the integer is 7, but the class is string. So whatever input you provide using the input function, it is taken and processed as a string. So in this case, the type is string, even though the number 7 is stored. So in this case, it's not integer 7 that is stored inside the result, but it's the string 7 that is stored inside the result. So what we can do here, the option we have is to put integer function in front of the input. What it will do, that whatever input we provide, it converts the input into an integer and then stores it inside the result. So let's run it again. And as you can see, enter an integer, we provide 7, and the integer is 7 and the class is integer, which works good. So we can remove this since we have already converted our input into an integer. But what happens if the user who is supplying the value does not provide a valid input? For example, in this case, let's provide an input as something. So we get an error. So as you can see in the line 21, we have an error that invalid literal for int with base 10 something. So as you can see, if you don't supply an integer, this line will provide an error. So let's try to solve this. Let's try to put this inside a try block. And then in the except block, we can put invalid input. Please enter a valid integer. And then in the finally block, let's put print the code will execute. This section will execute anyways. And if the user supplied a valid input, let's put it inside the else statement. Okay, let's do it. Enter an integer. Let's try a valid integer, that is 7. The integer is 7. This section will execute anyways. Again, let's do it. Enter an integer. Let's type A. Invalid input, please enter a valid integer, and this section will execute anyways. Now let's try to make it a little bit more better. And enter a while block here. Let's say while true. And okay, better. So here, this loop will go on and on. Here you can see invalid input, please enter a valid integer. So if the user is not providing a valid integer, we want to ask for the input again. So here, whenever we are asking for a valid integer, you can type continue, or even if you don't type, since it is true, it will go on executing again and again. But when you get a valid integer, which was in this case, the integer is result, you can put a break statement to break out of it. And that should do it. So if you run it, if you enter any invalid integer, for example, a, it will say invalid input, please enter a valid integer. And for the sake of this, we can even remove finally because it does not make much sense in this scenario. But as I demonstrated previously, you can use this. But let's remove it and run it again. Okay, so enter an integer, let's say 5. Let's restart it now. Okay, so enter an integer. We say a, invalid input, enter a valid integer. Let's put something else. So if we don't provide it, it will keep asking on it again and again. But when we supply a valid input, for example 7, you can see the integer is 7 and the loop breaks. So this is how you can use try, except, and else statement in your real world scenarios to do exception handling and to prevent your code from stopping whenever an error is generated. I'll pause the video to clean up this code so we can push it to our GitHub repository. Okay, so the code has been cleaned up and let's just push it. Let's save the file and use git status, git add. No. Okay. Yeah, better. Okay, then we can make the commit. Now we can safely delete the branch. Let's do a pull. And we have the fresh copy. Just to confirm, we are in the main branch and everything is updated. Okay, like, share and subscribe to follow the journey, and I'll see you in the next one. Keep defending.